Alright, we're still on section 1.6, but we're finishing, hopefully we'll finish up today. Make sure I don't go over 15 minutes. My other class, 15:20, they told me. I was like, oh no. So I went for like half an hour. And now I have to edit it. I don't know. Maybe I'll just put this one on their class. They'll probably never know the difference instead of taking the time to edit. Alright, let's do this. Let's talk about... now with this new operating system, it changed my screen resolution thing. And I used to be able to see all these things on my... There we go. But that's alright. It's not that big of a deal. What's this thing right here? It's a Pentagon. Good. Okay, but it's not just any old Pentagon. Let's listen now. You guys, here we go. We've started. Alright, so I expect you to listen to me now. It is a Pentagon because there's how many sides? 5 sides. Now, but there's something specific. Oh, wait. There's something that's particular about this Pentagon that's not necessarily true about every single Pentagon. And that would be, watch, what if I did this? Put a little mark here, a little mark here. What does that mean? What does it mean about the sides? They're equal to each other. They're the same, okay? If I did that, and I did this, and I did this, okay? So what must be true about all 5 sides here? They're all equal to each other, okay? They're all equal. Now what if I put a little arc right here and a little arc right here? Well, what does it mean about the angles, though? The arc doesn't mean it's obtuse. It means they're the same. That's right. It's kind of like those little tick marks, okay, except you use arcs. Now there's some books that do this. I don't think this book does. But watch, there's some books that do an arc, plus they put a little tick mark in it, just to show which angles are equal. So if that had 1 and this had 2, then this angle would be different from this angle. Follow me? This book doesn't do that. This book would do something like that. What if these 2 angles were different? This one would have 2 arcs, this wouldn't have 1 arc. Does that make sense? But these angles are all the same. They are all equal to each other. So we'll keep it like that. Now, we have a special name for this. If all the sides are equal to each other, which they are, right? And all the angles are equal to each other, which they are, we call that a regular polygon. That's pretty important. Some of the things we talk about, and I'll tell you, if we use it a lot or if we don't use it a lot, this one we use a lot. Okay, we use it quite a bit actually when we talk about a regular polygon. So if they say this is a regular, now polygon could mean any sides, right, from 3 on up. But so if I wanted to be real specific, I could also call this a regular what? Pentagon, right, to be a little bit more specific. But anything that's regular means that 2 things must be true. That all the sides are what? Equal. Or in geometry, a lot of times we say what? Congruent, right, congruent. Okay, or, Kelly, you watching? You writing this down? All the sides are congruent and all the angles are what? Congruent to each other. That's not a very good squiggly, is it? There, that's a better squiggly. Okay, all the angles are congruent. So in order to be a regular polygon, all the sides have to be equal and all the angles have to be equal to each other. That has to be true about a regular polygon. In another chapter, we're going to talk, I think it's another chapter. Yeah, I don't think it's this chapter, but another chapter, we're going to talk a lot more specifically about regular polygons. Right now, we're just touching on it. We're getting off of it, all right? But I want you to understand that we will be doing a lot more with this. So understand what this means. When I say a regular pentagon or a regular whatever, it means all the sides are equal. It means all the angles are equal. You got it? Now look, just because all the sides are equal to each other, does that necessarily mean that all the angles will also be equal to each other? No, that's not true. Now, it's kind of hard to use this picture to demonstrate that. I'm going to use a quadrilateral to demonstrate that. Okay? So watch. Let's change colors here. Let's go with purple. What if I did this? What would you call that type of figure right there? What would you call that? What is it? A rectangle. Okay? And you actually don't know it's a rectangle until you know what the angles are. Now you can kind of make an assumption what the angles are, but if I put these little boxes, now what can you say it is? Now it's a rectangle, right? If you didn't have those boxes in there, you're just making an assumption that those are right angles, because they might be just slightly off a little bit and you didn't know it. Would you agree? All right, but if you see the little boxes, that means they're right angles. Now, look at this. all four angles are equal to each other. Just because all four angles are equal to each other, does that mean that the sides are necessarily equal to each other? Is this a regular quadrilateral? Is it a regular polygon? No. What must have to be true to be regular? All the sides have to be equal, and all the angles have to be equal. You can't just have one or the other. You with me? All right, so look, this side is equal to this side, but guess what? All right, that's different, so we'll put two little tick marks on there, okay? So this is not regular. You with me? Because a lot of people think, after I talk about a regular polygon, a lot of people think that, oh, if all the sides are equal to each other, then it's regular. No. If all the angles are equal to each other, then it's regular. No. What has to be true? Both of them, right. The sides and the angles have to be equal to each other. Let me give you another demonstration of a of something that's not regular. Give me just a second. I'm going to do this. We'll do that. But I got to change things around just a little bit to make it look. Now, I can't say for a fact that that's all the same, but we'll mark it up. Okay, watch this. What if I said this? What if I said that that side and this side are equal, and this side, all of them have one tick mark? What does that mean about all four of those sides? All four sides are equal. But let's take a look. Is this a regular polygon? Is it a regular quadrilateral? No, it's not, because look at this angle. That angle's obtuse, and look at this one. This is acute. Do you see that? There's no way that those two angles are equal to each other, is there? All right, so that means, is this regular? No, it's not. So this has all the angles equal to each other, but it's not regular. This one has all the sides equal to each other, but it's not regular. You got it? What would a regular quadrilateral look like? A square. Yeah, equal sides and equal angles, right? And what is a quadrilateral that had equal sides and equal angles? That would be a square. What polygon? Okay, right angle is not a polygon. Okay, what polygon? Okay, well, not just any quadrilateral, but what? What is this thing? Come on, I said it just 2 seconds ago. It's a square. It's a square. Okay, a regular quadrilateral is also known as what? A square. That's right. Because what's a square have? A square has all four right angles. They're all equal to each other, aren't they? What else is true about a square? All the sides are equal to each other. So guess what this is? This is a regular polygon, or a regular quadrilateral, or you could call it a square. Any of those things, right? So you wouldn't call it a regular square, because a square means that all the sides and all the angles are equal to each other, okay? But I'd call it a regular quadrilateral. It's a regular quadrilateral, but what's another name that we know it as? It's just a square, okay? What if I had a regular pentagon? Do we have another name for a regular pentagon? No, not really, okay? What about a regular octagon? What do you probably see every single day? A stop sign. A regular octagon is a stop sign, isn't it? Would you agree? All right, if you want to, okay, I wouldn't suggest this, especially going at any kind of speed, but if you go up to the stop sign, pull out your protractor, right, stick it on one of the angles, and do that to every angle, I wouldn't do this, all right? You might get beat up if somebody sees you do this, all right? But if you try it, you'll find out that all the angles are equal to each other. If you take your ruler out and you measure all the sides of a stop sign, then you'll find out all the sides are equal to each other. So what is it then? It's a regular what? Octagon. All right, enough of that. Let's pause this and we'll go on to something else. All right, I've got another rectangle. We've already talked about that and all that kind of stuff, but let's go a different route with this. What if I wanted to find the distance around this thing? There's a word if I want to find the distance around. If I wanted to measure all the distance around the whole entire thing, there's a special word. It's not area. What is it? Perimeter, right. It's the perimeter. You ever hear of that? Sure, you've heard of that. You've done this back in middle school. Perimeter, right? I use a two-word definition. It's really simple. It's just the distance around. All right? Distance around. If you can remember that, you can find the perimeter. It's pretty simple. Everybody got that? The perimeter is the distance around. So if this was 5 and this was 2, and I asked you to find the perimeter, do you have to know some big fancy formula to be able to figure that out? No, just add up all the sides. Now, it's a rectangle, let's say. All right, so if that side is 5, guess what? This has got to be 5. If this is 2, then this is 2. So what do you do to find the distance around all these? Just add them up, right? 5 and 5 is 10, plus 2 and 2 is 4. So what's the perimeter of this? It's 14. Okay, so the perimeter is 14. Does that make sense? Okay. Now, what if you wanted to find the area? Area is a little different. What do you find when you find the area? If I split this up, 1, 2, 3, 4, 5, I get 5 columns this way, wouldn't I? If I split it this way into 2, I get 2 this way. How many squares would I get if this was 5 and this was 2? I would get 10 of them. It's kind of like in a classroom. If I wanted to count up how many chairs, now that's only got 4, but let's pretend it had 5. What if I had 5 chairs here, 5 here, 5 here, 5 and 5? 1, 2, 3, 4, 5. I got 5 in a row, and I got 5 rows. How many chairs do I have in the room? I got 25. I didn't have to count every single individual chair, did I? I just count how many rows and how many seats are in each row, and I multiply them together, and I've got that. That's what area basically is. All right? If I broke this up into 5 and 2, I would just count 5 across this way, 2 across this way, or up and down, and so that would be 10. That's the area. So the area, a lot of times we say length times width. You've heard that before, haven't you? So area is length times width. It doesn't matter which one you call the length and the width. A lot of people say that the length is always the longest side or the one going across. It doesn't make any difference. Okay? It does not make any difference at all which one you call what. Just call one side the length and the other side the what? The width. Now watch. If this is the length, you're not going to call this down here the length, are you? I mean the width, I'm sorry. They got to be the two different sides, okay? One's the length and one's the width. So it's easy. It's just 5 times 2, which is what? 10. Now, if this was in inches, 2 inches and 5 inches, it's 5 inches times 2 inches. What's inches times inches? Inches squared. So area is always squared. Perimeter is always just the units, okay? Just inches or meters or centimeters or whatever they tell you to use. You with me on that? All right, so that's how you find the area. Pretty simple. Area of a rectangle. Let's do this. Let's bring another figure in here. Oops, it's not what I wanted. Copy, paste. There we go. That's what I wanted. Let's do this. Actually, I'm going to just put this off to the side for right now. Let's go to a different color. What if I did this? What if I went from here to here? What did I just do right there? I split it into what 2 figures now? I got 2 triangles, don't I? Tell me something about those 2 triangles. They're exactly the same. They're both right triangles, that's true, and they're both exactly the same, aren't they? Okay, as far as the length and the width and all that kind of stuff. So really, I took that rectangle and I split it how? In half, right? And that's where the area of a triangle comes from. I'll put a T, area of triangle, is that okay? So area of a triangle, it's not the length times the width. For some reason, when they talk about triangles, they don't use length and width. They use something else. They use base and they use height. It's the same thing though, isn't it? As length and width, but they use the letters B and H for base and height. So watch. It's the base times the height, but this triangle right here, if I just wanted to find the area of just that triangle, it's not the whole entire base times height, because that would be the rectangle. What would it be? It'd be base times height what? Squared? I'm not going to square it. I'm going to divide it by 2. It's half of it, isn't it? Look, this triangle is half of the rectangle. You see it? So, look, half of the rectangle. The rectangle would be what? Base times height. Well, what's the triangle? It's half of the base times the height. Here's another way to write it. You could write it base times height divided by 2. Either way, it means the same exact thing. All right, so that is the area of a triangle right there. You might want to write the word in there. Thank you. All right, so we got that. Let's do a little bit more with triangles, but we'll do it in the next video because I'm running out of time here.